Hey everyone, in this video we're going to be talking about factoring by grouping. So factoring by grouping is another method that we use to factor a statement. We're going to go ahead and take a look at three expressions and we're going to factor all of these using factoring by grouping. Now with factoring by grouping, we're going to obtain answers that typically look something like this. We may have something like A plus B times C plus D. So this is a binomial times a binomial. This is what our answers will look like for the most part. Now, as opposed to factoring out the greatest common factor, if you recall, when you factored out the greatest common factor, we had some monomial expression, and then it was times a bunch of stuff in parentheses, however long it happened to be, but it was a monomial times something else. And if you distributed that monomial to each piece in the parentheses, you would end up with the original statement. Now, in the case of factoring by grouping, we're going to end up with answers that look like this: a binomial times a binomial. So if we wanted to check our answer for this for these factoring by grouping problems, we would need to be able to have the ability to multiply this together to obtain our original statement, just to check. So to do that, you may have heard of the foiling method, first, outer, inner, last. But what that means is you just want to multiply everything in here by everything else over here. So we take our A, we multiply it by C to obtain A times C. Then we take our B, multiply it by the C to get B times C. Then we take our A, multiply it by our D. And then we take our B and we multiply it by the D. So everything in the first set of parentheses here is multiplied by everything else in the second set of parentheses. You can think about it as distribution too. Like if you have a monomial times some expression, this monomial would get distributed to each piece in here. You could think about this as the same way. This A plus B is distributed to the C, which will give us the AC and the BC. And then this A plus B is distributed to the D, which gives us AD and BD. So it's the same type of concept, although it looks a little bit different. And if you've heard of the FOIL, that's first the two first terms, and then the O stands for the two outer terms, so A and D, first outer, and then the two inner terms here are B and C, and then last terms are B and D. But it doesn't matter the order in which you do this, as long as you make sure everything gets multiplied by everything else. So one thing you may notice about this AC plus BC plus AD plus BD, no matter what happens to be in these parentheses, you may notice if I multiply AC times, the AC times BD, I obtain ABCD, right? And if I multiply BC times AD, I also get ABCD. So we could take two terms of this expression, multiply them together, and we should get the other two terms multiplied together. It's possible if you pick the right terms. This is a test for factorability. So in other words, if we're given a statement that looks like this here, and we have the ability to multiply two terms together, and that's also going to be the resultant answer for multiplying the other two terms together, then that's going to be factorable. If you notice here in my first example, if we take 5y and multiply it by negative 6x, we get negative 30xy, right? And if we take negative 15 and multiply it by 2xy, we get negative 30xy. So this one here is factorable. And you may want to check for number 2 and you may want to check for number 3. Now you have to find the right pairing though to tell if it's factorable or not. You know, if I multiplied 5y and 15, you get negative 75y, and that's certainly not the 6x times 2xy. that just means, okay, either it's not factorable or you didn't find the right numbers to be working with. But in all these cases, they are going to be factorable, and this is one test to tell if it is factorable. So for number 2, notice how x cubed times 48 would give me 48x cubed, and this negative 12x times negative 4x squared would also give me 48x cubed. And I'll let you find the 2 terms you need down here too. So that's just the test. And that test comes from this fact right here with these the A, B, and the C and D. Now, next up, let's take a look at number 1. We want to factor 5y minus 6x minus 15 plus 2xy. So what we're trying to do is we're trying to group some of the expressions within this term here. If you try to factor this using the greatest common factor, you're going to see that you can't necessarily find anything in common between all 4 of these expressions. So we can't use that particular method. So next we may want to try factoring by grouping. How do we know is this factorable? Well, like I said before, the 5y and the 6x, you get negative 30xy, and the 15 and the 2xy, multiply those, you get negative 30xy. So we know it's factorable, but we have to now find how we could do that. So in order to do that, you have to group. So I multiplied these 2 together to get that negative 30xy. So those aren't the 2 terms that I want to group. You could group this 5y with any of the other 2 terms. You could group it with the negative 15, or you could group it with the 2xy, and I'll explain what I mean by grouping in a moment. So if we're going to pick that as one of our groups, we have to pick the remaining pieces to be in our second group. Now, let me rewrite this statement, but let me write it so that my groups are in order. So I have 5y minus 15. This will be my first group, and then my second group will be this negative 6x and positive 2xy. So all I did was I rewrote the statement in a different order so that my groupings are next to each other. Now, this is when we use the greatest common factor method here. We're not going to look at all four of these pieces individually, but we're going to be looking at the first group, and we're going to be looking at the second group like this. And we're going to see if we could factor out anything from the first group, and we're going to see if we could factor anything out of the second group. So let's see, if we have 5y and negative 15, what's the factor you could pull out of that? The greatest common factor? Well, it would be 5. And then what's left behind after you factor out the 5? Y minus 3. Okay, that's good. Now, for negative 6x and positive 2xy, what would the greatest common factor be? Well, we have a factor of 2 in common, and we also have an x in common. So we're going to obtain, once we pull this out, we're going to get negative 3 plus we have y. Okay, now if you notice here, we have 5 times y minus 3 plus 2x times, and notice here, this negative 3 plus y, that's the same as y minus 3, right? So let me erase this, and instead of writing negative 3 plus y, I'll write y minus 3. It's no difference though. Okay, so now, this was the goal, right? The goal was to factor these in such a way that we're going to end up with a common element over here, and we get a common element over here. This is y minus 3. And if you recall, you can factor out a binomial from the entire expression. So since they have a y minus 3 in common, we could write down the y minus 3 and factor it out of each piece. So once we do that, we open up a set of parentheses, and we see what's remaining. We have a 5 and plus 2x remaining. Right. Another, when I was learning this material, what I did once I got to this step, I just remember, okay, what you want here is the same binomial, and once you have that, you write it down, open up the parentheses. The other set of parentheses will just be the 5 and the positive 2x right here. But what we're really doing is we're factoring out this binomial y minus 3. So next up, let's take a look at number 2. We have x cubed minus 12x plus 48 minus 4x squared. We know this is factorable because the test says if we take x cubed multiplied by 48 here, we get 48x cubed. And these remaining two would also give me 48 cubed if they're multiplied together. So if you could find multiplications like that, then we know it's factorable. Now, this x cubed, I'm not going to pair it with the 48 because that's the number I used for the test. Those two you multiplied together to get 48x cubed. So if you want to factor this correctly, you can pair this with either of the other two terms, and the factorization will come out correct. I encourage you to go back to number 1 and try a different grouping method, the other one that I suggested. So if I take this x cubed, I could pair it with either negative 12x, or I could pair it with this negative 4x squared, and the math will come out correctly. So let me pair these two together, x cubed and negative 4x squared. And the remaining two, I'll pair those together. Alright, and once we follow the method, everything should come out fine. So let me rewrite this statement, but let me rewrite it in an order such that my groupings are next to each other. So x cubed minus 4x squared, then we have a minus 12x plus 48. So now my first group appears first, and my second group appears over here. So there's my first group, there's my second group. Now at this point, you want to factor these groups separately from each other. For this first group, what's the greatest common factor here? Well, they both have an x squared, so you could factor out an x squared. And what's left behind after you divide that out from each piece? We have an x minus a 4. Now over here, between negative 12x and a positive 48. Now I know that I'm going to want x minus 4 to appear in the parentheses over here, right? That's the goal of this grouping method, is to obtain that common binomial. So I'm going to factor out a negative 12 because you may want to use a little bit of foresight here. If you factored out a positive 12, you're going to be left with 4 minus x, but that's not what we want, right? We want x minus 4. So what we do is we just change the sign of what we want to factor out to manipulate the signs that are within the parentheses. And I see if you factor out a negative 12, what's going to be left here is if you factor negative 12 out of negative 12x, you're left with an x. And you factor negative 12 out of 48, you're left with a negative 4. And that's what we wanted, right? So now this is good. And one thing I want to point out when doing these problems is it's important to keep this as a coherent expression going through these. You don't want to separate these two in any way. This is one coherent statement. I write this expression here, and then I'm writing this expression here. A common mistake is for students to think that this part here is being multiplied by this first part, but that's not the case here. We have x squared times a binomial, and then minus 12 times this binomial here. All right, so just one coherent statement. And once we get to this point, you could realize, okay, I have the same binomial, so I'm going to go ahead and write down that binomial, x minus 4, and what's in parentheses next to it should be x squared minus 12. And that's going to be the factored form. And again, how we got to this step here, you could either memorize that's how you do it, or what we're literally doing is we're factoring out the x minus 4, and what remains is x squared minus 12. So this is the factored form, right? These two pieces will multiply together to obtain our original expression, and that's the goal of factoring, right? Now, if you wanted to check your answer, as I mentioned, I didn't do this for number 1. You could go back to number 1 and try it. But if you wanted to check your answer here, we could do x times x squared. That gives us x cubed, right? And then negative 4 times x squared would give us a negative 4x squared. And x times negative 12 will give me negative 12x. And lastly, negative 4 times negative 12 gives me positive 48. And this is the same expression as up here, right? It's in a little bit different order, but that order doesn't matter, right? For adding here. So x cubed, and there's our negative 12x, we have our 48, and we have our negative 4x squared. So we know this is the correct factored form right here. Now let's move on. Let's go ahead and check, let's try number 3. First of all, this is factorable. Let's see if we could find the right numbers here. If we take 6x cubed and multiply it by 5, we get 30x cubed. If we take these two middle terms and multiply them together, we also get the same thing, right? 30x cubed. And that is telling us that this is factorable. So now, let's see how we could do this. When I took this number, I multiplied it by the 5, right, to get that 30x cubed. So what that means is if you did the test, you would have to pair the 6x cubed with either the negative 2x squared or the negative 15x. Either grouping will work. So let me group the first two terms, and let me group the second two terms. So now there's no reason to rewrite this because my groups are already in a nice order. I have the first two and the second two. So I'm just going to go ahead and take a look at the first two, and we're going to factor out the greatest common factor here. So 6 and 2, they have a factor of 2 in common, and then x cubed and x squared has at least 2 x's apiece, so we could pull that out. And what's remaining? We'll have a 3x minus 2x squared times what gives me 2x squared? Just the 1, right? Okay, and for the second grouping here, I know that I want a 3x minus 1 inside the parentheses over here. So instead of factoring out a positive 5, I'm going to factor out a negative 5, open up the parentheses, and what's remaining? It'd be 3x, and then negative 5 times what gives me positive 5? Well, that's negative 1. Okay, so I ended up with 3x minus 1 in parentheses here as well. And then once we get to this step, our factored form here is going to be, because we factor out a 3x minus 1, we write that down, open up the set of parentheses here, and what's remaining is 2x squared minus 5. And this is the final answer, but if you wanted to check your answer, you could do the 3x times 2x squared. That will give us 6x cubed. The negative 1 times 2x squared will give us negative 2x squared. The 3x times negative 5 will give us negative 15x, and the negative 1 times negative 5 gives us a positive 5. So we know that this is the correct factored form. So that's it for this particular video. You know, this is just another method that we have to factor things. There's going to be quite a few different methods, but so far we have the greatest common factor and factoring by grouping. And this particular method actually uses the greatest common factor method too. So I hope you enjoyed this video, and I'll see you in the next one.